Hello everyone, and welcome to today's GCSE Physics lecture. In this session, we're diving into a fundamental concept: energy stores and transfer. By the end of this video, you'll have a clear understanding of these concepts along with real-world examples. Let's get started. To begin, let's define what we mean by energy. In physics, energy is the capacity to do work or cause a change. It comes in various forms, and we measure it in joules J. Energy is a property of body that must be transferred from one point to another in order to do work. Examples of energy: a child playing tire swing, a woman doing exercise, kids playing seesaw, a boy climbing the building. To begin, let's define what we mean by energy. In physics, energy is the capacity to do work or cause a change. It comes in various forms, and we measure it in joules J. Energy is a property of body that must be transferred from one point to another in order to do work. Examples of energy: a child playing tire swing, a woman doing exercise, kids playing seesaw, a boy climbing the building. First up is the kinetic energy store. This is the energy an object possesses due to its motion. Imagine a moving car. The faster it goes, the more kinetic energy it has. So, the kinetic energy store is linked to the speed of an object. Next, the gravitational potential energy store. This energy is associated with an object's position in a gravitational field. Consider lifting a book off the ground. The higher it goes, the more gravitational potential energy it gains. Gravity and height play crucial roles in this store. Now, let's talk about the elastic potential energy store. When you stretch or compress these objects, you're storing energy in their elastic potential energy stores. The more you stretch or compress them, the more elastic potential energy they gain. This energy store is related to the deformation of objects like springs, rubber bands, or even a trampoline when you jump on it.
Now, let's expand our understanding to include the electrostatic potential energy store. This energy is associated with the interaction of charged particles. When charged objects, like two repelling or attracting charges, are brought close together or moved apart, electrostatic potential energy is involved. Now, let's explore the nuclear energy store. This form of energy is stored in the nucleus of an atom. Nuclear reactions, such as fission or fusion, involve the release or absorption of nuclear energy. In fission, the nucleus of an atom splits into two, releasing a significant amount of energy. In fusion, two atomic nuclei combine to form a heavier nucleus, releasing energy as well. Nuclear energy is harnessed in power plants to generate electricity and plays a crucial role in both natural processes and human technology. Moving on, the chemical energy store. This is the energy stored in the bonds between atoms and molecules. Think of food. When you eat, your body breaks down these chemical bonds, releasing energy that your body can use. Now, let's discuss the thermal energy store. Thermal energy is associated with the random motion of particles in a substance. The higher the temperature of an object, the greater its thermal energy store. When you heat a pan on a stove, the thermal energy of the pan's particles increases, and you can feel this as heat. Understanding the thermal energy store is crucial for explaining processes like conduction, convection, and radiation, which involve the transfer of heat energy.
Now let's look at the exam question, appeared in October-November 2019. Brakes are used to slow down a moving car. Into which form of energy is most of the kinetic energy converted as the car slows down? Option A: chemical. Option B: elastic. Option C: thermal. Option D: Sound. The correct answer is option C. Thermal. Because when a car slows down using its brakes, the primary form of energy conversion is into thermal energy. This is due to the friction between the brake pads and the rotating parts of the wheel. The kinetic energy of the moving car is transformed into heat, thermal energy, as a result of this friction.
Let's look at exam question detailing how the gravitational potential energy is converted into kinetic and internal energy. A stream flows out of a lake and down the side of a hill. What best describes the change in energy stores? Option A, kinetic energy, chemical energy plus internal energy. Option B, gravitational potential energy, kinetic energy plus internal energy. Option C, gravitational potential energy plus kinetic energy, internal energy. Option D, kinetic energy, internal energy plus gravitational potential energy. Take some time to figure your correct answer. When water flows from a lake down a hill, its stored gravitational potential energy is converted into kinetic energy due to motion and internal energy due to friction. The correct change in energy stores is Option B, gravitational potential energy, kinetic energy plus internal energy. This describes the energy shift from potential to kinetic and internal as the stream moves downhill.
Now that we've covered energy stores, let's shift our focus to energy transfer. Energy transfer occurs when energy moves from one place to another or changes from one form to another. Some common examples are mechanical, electrical, heat, radiation. Let's explore these options one by one. Mechanical work is one way energy is transferred. Consider lifting a backpack. The work you do transfers energy to the backpack, giving it gravitational potential energy. Mechanical work involves the transfer of energy through physical actions. Electrical work involves the transfer of energy through electrical currents. Example, turning on a light switch allows electrical energy to be transferred through the circuit, providing energy for the light bulb to emit light. This is a common example of energy transfer in our everyday lives. Another common mechanism is heat transfer. This occurs when energy is transferred from a warmer object to a cooler one. Example, placing a metal rod in a flame causes thermal energy to be transferred to the rod through conduction, raising its temperature. Let's not forget radiation. Energy can be transferred through electromagnetic waves, such as light or radio waves. The sun's energy reaching the earth is an example of energy transfer through radiation. In fact, even as we sit here, our bodies are radiating infrared radiation, contributing to the thermal energy transfer around us.
Let's look at another exam question. A student suggests that there are several ways of transferring energy to a small, stationary block of iron on a smooth table. He makes the following suggestions. 1. Heat it. 2. Shine light on it. 3. Pass a current through it. Which suggestions are correct? A. 1 and 2 only. B. 1 and 3 only. C. 2 and 3 only. D. 1, 2, and 3. Take some time to figure correct answer. So here we're evaluating methods to transfer energy to a stationary iron block on a table. The student's suggestions are 1. Heating it transfers thermal energy. 2. Shining light on it transfers energy through radiation. 3. Passing a current through it transfers electrical energy, which is then mostly converted to thermal energy due to resistance. Each method introduces energy to the block in different forms. Therefore, all suggestions are correct methods of energy transfer. Conclusion: the correct answer is D. 1, 2, and 3. All methods can transfer energy to the block of iron. Another exam question states that which device is designed to convert chemical energy into kinetic energy? A. An AC generator. B. A battery-powered torch. C. A car engine. D. A wind-up mechanical clock. Take some time to figure correct answer. The device that directly converts chemical energy into kinetic energy is the one that uses fuel to create motion. Option C, a car engine, is designed to convert chemical energy into kinetic energy.
When you start a car from rest, accelerate along a road, and then suddenly apply the brakes to stop, a series of energy changes occur. Let's dissect the process. First, starting the car. Input energy. Initially, you provide chemical energy to the car's engine by burning fuel, typically gasoline. This chemical energy is converted into kinetic energy as the engine components start moving. Some energy is lost to friction and other inefficiencies in the engine. Second, acceleration along the road. Conversion to kinetic energy. As the car accelerates, the chemical energy continues to be converted into kinetic energy. The car gains speed, and its kinetic energy increases. Air resistance and friction. However, some energy is lost due to air resistance, aerodynamic drag, and friction between the tires and the road. These losses are usually in the form of heat. Third, applying the brakes to stop. Conversion to thermal energy. When you suddenly apply the brakes, the kinetic energy of the moving car is converted into thermal energy. The brake pads create friction with the rotating parts of the wheels, causing them to heat up. This process rapidly decreases the car's kinetic energy, bringing it to a stop. Sound energy. Additionally, some of the kinetic energy may be converted into sound energy, especially if the brakes screech. When a stone is thrown up into the air, we observe a series of energy transformations. Initially, the person throwing the stone imparts kinetic energy to it. As the stone ascends, gravitational potential energy increases while kinetic energy decreases. At the highest point, when the stone momentarily stops, its kinetic energy is entirely converted into gravitational potential energy. On the way back down, the potential energy is transformed back into kinetic energy. Throughout this motion, some energy is also lost to air resistance in the form of heat. In summary, the energy transfers involve the conversion between kinetic and gravitational potential energy, with a small amount lost to air resistance. When using a gas cooker to boil an egg, we witness a chain of energy transfers. The process begins with the chemical potential energy stored in the gas, like methane. As the gas combusts, this chemical energy is released in the form of heat. The heat is then transferred to the base of the pot. The pot, being in direct contact with the gas flame, conducts the heat to the water inside. The water absorbs the thermal energy, causing its temperature to rise. As the water boils, the heat is transferred to the egg. The egg, being in the hot water, absorbs the thermal energy, and its contents cook. So, we have a sequence of energy transfers involving chemical energy, thermal energy, and heat transfer, ultimately leading to the cooking of the egg. When the sun warms up sand on a beach, energy transfer occurs through radiation. The sun emits electromagnetic waves, including visible light and infrared radiation. As these rays reach the earth, the sand absorbs the sunlight. The absorbed solar energy is then transformed into thermal energy, causing the sand particles to vibrate and gain kinetic energy. This increase in kinetic energy is experienced as a rise in temperature. Some of the energy is also reflected or re-radiated, contributing to the overall warming of the surroundings. In summary, the sun's energy is transferred to the sand through radiation, leading to the conversion of solar energy into thermal energy in the sand.